Example 1, let Sn be the statement 2 plus 5 plus 8 plus ... plus 3n minus 1 equals n times 3n plus 1 over 2. Prove that Sn is true for every, I think that's supposed to say, positive integer n. All right? So we're proving that that's always true. You've got 2 steps. Start with step 1. Show S1 is true. All right, so on the left side of the expression that was given, S1 is just 2. The sum of the first term on the left is going to be 2. So we want to figure out if that equals what we would get on the right side if we plugged in 1. Basically, we're just plugging in 1. So on the right side, that says 1 times 3 times 1 plus 1 over 2. You're going to have a lot of algebra to do in this lesson. The more you can do in your head, probably the better. But 3 times 1, that's 3 right there, plus 1 gives me 4. We've got 1 times 4 over 2. 4 over 2 gives me 2. And so we've got a true statement. Check. S1 is true. Now, that does not prove that all of the dominoes fall down. This only proves that the first domino falls down. Okay? I know the first domino falls down. Step 2 is the hard part. We want to show that SK true leads to SK plus 1 true. I'm going to start with an assumption. Assume. And then what you're going to do is you're going to take that expression that they gave you, that statement, and you're going to plug in k in place of n. So replace n with k. You would see 2 plus 5 plus 8 plus ... plus 3k minus 1 equals k times 3k plus 1 over 2. All right. So I'm assuming that's true. I'm starting with that assumption. I'm saying that there's some domino off in the distance that falls down. All right. What I have to prove now is that the next domino falls. So if k is some number, then the next domino is going to be k plus 1. So on the right side of this expression, you just have to change k to k plus 1. All right? But on the left side of this expression, you have to show that sum with the next term. Okay? So look at what we've got. We've got 2 plus 5 plus 8 plus ... plus 3k minus 1. It sure looks like I'm just copying down the statement, okay? But I've got to add the next term on there. And so the next term is going to be 3 times k plus 1 minus 1. Essentially, all I did was I took that k and made it a k plus 1. That's going to be my next term. 3 times the next thing minus 1. Every single one of those. 3 times the next thing minus 1. Now, the right side of this expression, you just take your k and change it to k plus 1. That's your next term. So we're going to have k plus 1 times 3 times k plus 1 plus the 1 all over 2. Now, I don't have a whole lot of room on the right side, but you do. Technically, we should write a question mark right there. All right. We are trying to prove whether or not that's true. All right. We are trying to show that that next term is true, or that next domino is going to fall down. And this is going to just require a whole lot of algebra. We're going to FOIL. We're going to combine some like terms. We're going to do a substitution. We're going to have to deal with fractions. We're going to simplify a lot of algebra. There's a lot of algebra in this problem. Okay? But the main idea is we have to show that that left side of the expression is going to be equal to the right side of the expression through algebra. Okay? So might help to draw a line right there just to keep your sides separated. Here's what you need to do. Okay? See that purple? That purple is a perfect match for the left side of the step that I assumed. I assumed that that part was true, and so we're going to do a substitution. The first thing I'm going to do is substitute that left side of that expression for the right side of my assumption. Notice that that purple right there is exactly equal to k times 3k plus 1 over 2. That's coming straight from my assumption in the row right above this. Then the black, I would probably distribute. Distribute right here, distribute that 3. That's 3k plus 3, right? 3k plus 3, and then I'm going to go ahead and subtract the 1. That's going to be plus 3k plus 2. All right, so I did two things in my head there. I distributed the 3 and got 3k plus 3, and then subtract the 1. So you're trying to look for, does the left side equal the right side? Okay? And you can kind of see, you can kind of guess, yeah, maybe they do. I see a 3, and I see a over 2. I see some stuff that looks kind of similar, but we're not there yet. We've got to do a lot of cleanup here. For 1, I would probably distribute this k. I'd have 3k squared plus k over 2. But then I would also multiply by 2 over 2 because I want to get a common denominator. Okay, I want a common denominator. I can distribute this 2, and that's going to make plus 6k plus 4 over 2. And then I can combine my fractions. 3k squared plus 7k plus 4 all over 2. Again, keep your eye on the prize. What we're trying to do is show that the left side of this is equal to the right side of this. You may be feeling like, okay, maybe it does, okay? But we haven't really gotten there yet. We haven't proven it yet. I'm going to try to clean this up. Let's distribute this 3. That would say 3k plus 3. And then go ahead and add this 1 on there. That's 3k plus 4. So this right side would be k plus 1 times 3k plus 4 all over 2. Those might be equal. I'm going to test it out by foiling here. Let's do a double distributive. That's going to be 3k squared plus 4k. Distribute, that's going to be plus 3k plus 4 over 2. All right, now I can tell this is going to work. This is going to work. Look at your like terms. You got 3k squared plus 7k plus 4 over 2. You see how the left side is equal to the right side? That proves it, okay? That proves that this is going to work for sk plus 1. All right, so we've done it. There's a Latin phrase, QED. I don't know how to pronounce it, I suppose, but I think it's quod erat demonstrandum. I just demonstrated what I was supposed to demonstrate. I just showed you what you needed to show. The left side is equal to the right side, and so I just did it. I know that SK gave me SK plus 1. And so the answer is this whole thing. It's a proof, okay? I might just add this to the bottom of the statement, though. I might say something like this. Therefore, Sn is true for all positive integers n. Now that's not the answer. The whole thing is the answer. This is a proof, but that just kind of wraps it up.